On the morning of September 1st, 1859, British amateur astronomer Richard Carrington was in his private observatory outside London, sketching sunspots through his telescope. Just before noon, two bright white patches of light erupted from the sunspot group, expanding rapidly across the solar surface before fading. It took exactly 17.5 hours for the result of that flash to cross the vacuum of space and slam into the Earth. What arrived was the largest geomagnetic storm in recorded history. The aurora borealis flooded the night sky, reaching as far south as the Caribbean, Cuba, Mexico, and Hawaii, latitudes where auroras are essentially never seen. In the Rocky Mountains, the glow was so intense that gold miners woke at 1 a.m. and began making breakfast, certain the sun was rising. In the trees, birds began to sing. Meanwhile, the global telegraph system was collapsing. Operators reported sparks showering from their equipment, shocking them and setting paper files on fire. Some telegraph machines even continued to function without their batteries. They were running entirely on ambient electrical current flowing through the lines from the storm itself. Humanity's first global communication network had been instantly turned into a live, uncontrollable electrical hazard by an unseen cosmic force. This is a solar flare, a massive eruption of electromagnetic energy from the sun's surface. Carrington's observation was the first time one was ever recorded. The primary threat is a coronal mass ejection, a massive cloud of magnetized plasma. Most take 3 days to arrive, but the 1859 storm hit in 18 hours. A prior ejection swept the ambient solar wind away, letting a second wave travel 4 times faster. On the modern NOAA scale of geomagnetic storm severity, the Carrington Event classifies as a G5, the maximum possible level. Ice core samples show it was at least twice as powerful as any other storm in the last 500 years. To understand the scale, consider the March 1989 storm. It was significantly smaller than the Carrington Event, yet it knocked out power for 6 million people across Quebec in just 9 hours. While a massive CME in 1859 merely burned telegraph paper, an identical storm hitting our modern infrastructure today would trigger devastating continent-wide physical failures. Researchers at Lloyd's of London estimate that a Carrington-scale straight train could cost the United States alone up to $2.6 trillion. These storms induce electrical currents in the ground that flow into any long conductor connected to the Earth. In a modern setting, that current flows directly up into our high-voltage transmission lines. The current eventually hits these high-voltage power transformers. They are the most critical and most vulnerable points of failure in the entire grid. These transformers are custom-built, with lead times of up to 3 years. They are so expensive and specialized that they are almost never kept in stock as spares. A direct strike could destroy hundreds or even thousands of these units simultaneously across a hemisphere as their internal components melt and fail. Because this hardware cannot be quickly replaced, a direct strike would force half the planet to live without electricity for months or years, while the global manufacturing chain struggled to rebuild the grid. We know this isn't just a historical curiosity. A Carrington-class ejection was launched from the Sun as recently as July 23, 2012. This diagram shows the orbit of the Earth. The 2012 ejection missed us by only 9 days, the distance our planet travels in its orbit in just over a week. We now monitor space weather continuously using spacecraft positioned between the Earth and the Sun to act as an early warning system. Even with those instruments, we would only have between 15 and 45 minutes of notice before a fast-moving CME reached our atmosphere. Our only viable defense in that window is to execute an orderly global shutdown of the entire electrical grid before the wave impacts the surface. Our survival hinges on the unproven hope that governments and utilities are prepared to pull the plug on modern civilization with only minutes to spare. Next episode, Winston Churchill. We know him as the man who more than anyone else kept Britain fighting in 1940, standing firm against the Axis powers when the odds seemed impossible. But he was also responsible for brutal strategic decisions that cost hundreds of thousands of lives. We will explore the full, honest story of his leadership and the legacy he left behind. From the physics of a solar storm to the life and death calculations of a wartime prime minister. Join us for the next installment.